Earth doesn't have any relative motion. If there was, we'd see Coriolis effect. Things would drift apart at 15 degrees an hour if there was relative motion.
Well, I had to do a special video this morning. I needed to address that for him. I have about 10 proofs of Coriolis. If he would like to debunk those, I've asked him at least 100 times to have a debate. He seems to be a coward and want to hide behind his own soundboard there. So the first thing, measurements of sunrise prove rotation. I have myself taken sunrise observation data and proven the rotation speed of the Earth, and that at the equator it's 1,037 miles per hour. At the latitude that I'm at, it's much less than that, and there's no way on a flat Earth that you can have the sun at different speeds. The second thing is prevailing winds. The prevailing winds, we may not have talked about that recently, but absolutely prove Coriolis. There are trade winds that sailors have used for eons that blow from northeast in Europe toward the southeast, or southwest, I'm sorry, northeast to southwest. In the westerlies, where I live, winds go from southwest to northeast. We find that I watch the weather almost every day, and our winds, you can almost guarantee, out of the southwest. So I've seen that from observation. So this, by the same logic, tornadoes. I asked someone that's familiar with meteorology and storms. Every single tornado goes from southwest to northeast. The path of the tornado. They have maps that mapped every single tornado. They all go from southwest to northeast. They all turn in the counterclockwise fashion that we're familiar with for the north hemisphere. Hurricanes. Hurricanes start at the equator, somewhere near the equator, and in the northern hemisphere, every one spins counterclockwise every time. In the southern hemisphere, hurricanes spin clockwise every time. And it's interesting, I have a map, you can look it up. Hurricanes never, ever cross the equator. You look at a map, there's like a little band around the equator where there has never been a hurricane, ever. So all of that speaks to Coriolis. This year, sometime this summer, I think, in June, they had a huge, massive sandstorm that came out of Sahara Desert. You may recall that happening because it was all in the news. That sandstorm went from the east to the west and up into the Caribbean, just exactly like hurricanes go. It followed exactly the Coriolis. Ocean gyres and ocean deep currents all follow Coriolis. You can look at maps and you can see, of course, they're blocked by continents, but the general pattern is exactly the same as Coriolis. I forgot to mention when I was talking about winds, jet streams. Good old Nathan Thompson always says, if the Earth was round, when air currents going higher up would need to go faster, well, guess what, Nathan? They do. They do go faster at high altitude. It's called the jet stream. In the northern hemisphere, the jet stream goes from west to east at about around 200 miles per hour. You think what that 200 miles per hour would be like in your backyard. In the southern hemisphere, guess what, Nathan? West to east. All high altitude winds blow from west to east, following the Earth's rotation. Prevailing winds are underneath that, and they follow the Coriolis. So that's the jet streams. Along with ocean currents around the equator, there are equatorial currents that go from east to west. Again, it's because of the drag of the rotation of the Earth. Laser ring gyro that Nathan Oakley's been talking about lately, it measures the rotation of the Earth. It works by what it's setting on. It does not measure the sky. It measures what it's setting on. Look down at the Earth. Have you heard that before? The laser ring gyro, if you look it up, which flat earthers don't want to research real stuff, but that's the way it works. It's based on the Sagnac experiment, which I know Nathan Thompson likes to quote how great that Sagnac experiment is. The Foucault pendulum. This is another one that Nathan Oakley quotes all the time. The Foucault pendulum. You have to start the pendulum moving. Most of the time with the really, really large pendulums, they have a tiny motor that gives the pendulum a little push to keep it from slowing down to nothing. The motor's not strong enough to affect the swing. All it does is just give it a little shove. But that pendulum, once it's started, it swings in a plane the way that it's meant to. The Earth spins underneath it because it's moving. If you stop the pendulum and let it hang, it will turn with the Earth's rotation just like any other object. Your airplanes, your helicopters hovering, your drones, they're all still. They remain still so that they follow the Earth and the atmosphere. yes, the atmosphere turns with the Earth, but it's a gas, so it kind of gets dragged along because of friction. It slows up. Okay? So the pendulum swings and shows the latitude because it's moving. Okay? It has to be moving to do that. And you notice Nathan Oakley never mentions the fact that the pendulum swings at a given rate based on the latitude of the pendulum. And they have them all over the world, and you can watch that they swing at a rate based on the latitude. And I've seen videos of a pendulum at the South Pole. So that's another thing that flat earthers can't explain. Why does it swing the way it does if you're saying that Coriolis doesn't affect it at all? Okay? So this is my video for Nathan Oakley, all about Coriolis, because I want to help him get over his aneurysm. We sure don't want any additional illness around this time, okay? So if you see Nathan Oakley, tell him how that you're sympathetic with him being ill, and let him know that David Emery is counting on him someday to do a debate. That's all I have today.